the people that cannot join right now. Okay, so good morning, good afternoon. I can start with the people from the GLC that will make this, will host this meeting. Maybe Marco, you can introduce yourself.
Yes, good morning or afternoon, everyone. My name is Claire Marco. I'm working in GLC as a contact person and responsible for the ClimSA administrative arrangement we have.
Thank you. And Vijay.
Hi everyone. I'm Vijay Charan. I'm working as a backend developer for the climate station. Thank you, Christoph.
And Jurjen.
Yeah, hello everybody. I am Juriaan van Klooster, and I'm also part of the team of the core developers, let's say, of the climate station.
Okay, thank you. And myself, so I'm Christoph Lavais. I'm working in the same team with Jurjen, Vijay, and Marco, and I'm a thematic expert and in charge of also the dialogue with RCCs. So we can now going to the different participants. I see Abani Ahmed Ali.
Yes, I'm Abani Ahmed Ali, IT department at ACMAD, working on the climate station.
Thank you. Dyson Lowe.
Yes.
If you can introduce quickly yourself.
My name is Jason Lowe. I'm the IT specialist at CIMH. I help maintain and run the network, and I'm also a software developer too. Nice.
Thank you. Dr. Faka, if you can introduce.
Yeah, thank you. Hello, everyone. My name is Dr. Faka. I'm the team leader of a ClimSA project at the OECPS Secretariat. Thank you.
Thank you. Eunice.
Hi, everyone. My name is Eunice Koech. I'm a forecaster from ICPAC. Thank you.
Thank you. We have Pierre Kamsu.
Hello, everyone. This is Pierre. So I'm Pierre Kamsu from ACMAD. I'm senior forecaster. I'm forecasting weather and seasonal forecasting here in ACMAD.
Okay. Romeo.
Good afternoon, everyone. My name is Romeo Nkurunziza. I'm a climate change analyst at ACMAD. Thank you.
Thank you. Good representation of ACMAD today. And Tiro.
Good afternoon, everyone. My name is Tiro Nkemela. I'm engaged with the SADC ClimSA TA as a junior climatologist. Thank you.
Okay. Thank you. I think I'm okay. Did I forget somebody? I think no. Okay, so we have 4 RCCs represented today. So it's interesting. So I will also share them, and also if you're interested of the information we're going to share today, of course the record of this meeting will be on Teams. And I think I will send a message to everyone after the meeting once the document will be shared. So as the previous meetings, the idea is to give you some updates of the development of the climate station, some information we can share with you. We can have a short presentation on the use of the wet and dry spells forecasts. So it's an indices we propose into the climate station. And today we're going to introduce you the methodology to develop it, the validation, and how to use it. The last part, and it's a big moment, very important also for us, is the moment where we collect in feedbacks from yourself. I mean, we have now the climate station installed in 7 out of 8 RCCs, or 6 out of 8. I think it's very important to collect the first feedbacks to improve the climate station, to facilitate your use. And if you want to change, if you can request some new data sets or improvement of the tools. So it's a very important moment for us to collect your feedbacks. So we're going to start now with some updates of the situation for the climate station. Maybe Vijay will introduce this part for just a couple of minutes.
Okay, thanks, Christoph. So on the installation, we installed almost on the 6 RCCs, except MOI and then spread. Apart from this institution, we already installed the upgrade 1.1.1. And then for some of them, we also introduced the portfolio, how to activate the chains of the portfolio, because for some of them, it was much faster, the installation. So we spent much less time on the installation upgrade, and then we started working on the other modules, which is new in the climate station. Whereas for some people, it was not easy to install on the same day because of the internet connectivity, etc. So we took some time, and then only the installation, the upgrade was done. So we couldn't really explain everything, but we decided to have a separate session on explaining everything from the portfolio, how to activate the processing chains automatically from the portfolio. All these things will be dealt in the upcoming session. So I guess some RCCs we already introduced, but still, yeah. Also, we have many more products requested from other RCCs in the past. So we will introduce all these things in the next section, common session. So that is from my side on the upgrade.
Okay, thank you. We just have 2 more people joining, Dario and Sherry. You can maybe briefly, so we had a previous tour de table. So if you want to know the others, you will watch on on the video we recorded. But could you please introduce yourself, Dario, maybe first from the GRC? Ah, okay. He has no mic and the camera. But so it's so I will introduce for. I can introduce for you is also a colleague from the GRC, and is responsible of the impact toolbox that is included into the climate station. Is working in a different unit, in the forest unit, and maybe we can give the floor to Sherry.
Hi, morning everyone. Sherry Frederick, Program Manager with the ClimSA program in the Caribbean region. I'm Cedric Van der Beek and Sean Boyce. They're supposed to be on the call, but I think we had an issue in terms of the time. I think we had calculated for 11 a.m. our time. So I'm trying to get in touch with them. Cedric is our climatologist, as you know, and I'm sure he would like to be on this call, but at least we're recording it. So as I said, I'll try to get in touch with them and see if they can make it.
Yeah, I mean, we're going to start in a couple of minutes.
Yes, sure.
Okay, so we can give the floor to Umaru, which is also joined the call. Umaru, if you can introduce yourself.
Sorry, I just get connected, so I'm not aware of.
No, it's just we just made the tour de table.
Okay,
all of us. So if you can just introduce yourself.
Yeah, thank you, Christoph. We were facing a lot of problem of internet connection in Niamey since 2-3 days. So I'm Mr. Moulay Umaru, working as a system manager in Agrimet Regional Center. I'm the one of the people that installed the climate station under UAF directive, and now the climate station is working, but nobody is using this climate station in Agrimet at this time. It's important for me to to tell this because I don't know what's happened, but we are not still able to use all the data coming from this climate station.
For technical, it's technical issues, or
no, I think because for technical, we don't have any problem on technical issue, but the problem is that the thematician doesn't have any training to use the climate station.
Okay, so I hope they will join today because it's a training today.
Yeah, I'm not seeing any of our thematician connected, so this is the problem, Christoph. So
yeah, but I mean, in any case, all the meetings are recorded on the use of the date of the. Again, I will send a message later. But all those meetings, the 3 of them, it's the 3rd today. All the past meetings, or the 2 past, on the use of the basic functionalities of the climate station, and on the use of the Jupyter Notebook. Is what was presented previously, so it gives some helps on the daily usage of the climate station. So yeah, I mean so all those meetings are recorded and we put it into our Microsoft Teams. I will share the link after the meeting. So if they are not here, that's pity, but at least they can see the videos, the recorded videos. And in any case, if they have issues of using the data we propose, if they need data sets, I mean, it's important they come into their sessions to facilitate the communication with us and to improve the system if they consider it's not good or it's not accurate or there are some data missing. So I think it's if you can give if Umaru, you can pass the message that the only way to improve the use of the climate station from your side is to interact more with us, so we can improve the system, or we can communicate even more. Okay, and just the last person that will have the chance to introduce herself, Sunshine herself. So if we made a tour de table, if you can give some, if you can give a few words about what you're doing at ACMAD, Sunshine Gamitze, if you have a mic. If not, okay. So if it's fine for everyone, I don't see.
Hello, Christophe. Hello, Christophe.
Oui,
can you hear me?
Oui, yeah.
Yeah, this is Sunshine. Yes. How are you?
Oh, fine, thank you. So could you introduce yourself? A few words about what you're doing.
Oh, okay. Yes. I hope you all can hear me. My name is Sunshine. I'm a climate expert here with ACMAD at ACMAD, and also coordinate the ACOF process. With Christophe is aware of that. Yes. Okay. So so in the issues around climate data and.
Whoa! Your mic is leaving.
Oh, sorry. Can you hear me now?
A bit, yeah, not so. I mean,
yeah, it's because I'm using
very
the
good.
headphones. I'm using the headphones.
Okay.
Let me remove them and see if something will be better. Let me remove them and try. Hello, everyone. Can you hear me now?
Yes.
Oh, thank you. Yes, I've removed the headphones. Also, I was saying my name is Sunshine. Here at ACMAD, responsible for. I'm a climate expert responsible for issues around data, climate data, climate monitoring, and specifically seasonal forecasting. But I also coordinate the ACOF, as I was saying, that Christophe is also a member, the ACOF process that we run monthly for now. I think with time, we'll maybe move to a usable time space. So my participation here, I think, is mostly on the climate products in terms of guiding the process and contributing to the process of developing climate products, and also climate data sets that will need to produce those specific products. Thank you.
Thank you very much. Okay, it's fine. I think it's time to move to the next step, to the presentation. So I'm sorry for Cedric, I hope. Yes? Okay. Okay, I hope you see my screen.
Yes, we do.
Everything
yes.
Okay. So, okay, the idea today is to introduce you, to have a better view of one of the products we have implemented into the system, into the climate station. And it's a work we did in the past, and we have adapted for the climate station. It's the global forecast of extreme anomalies of cumulative rainfall. And so basically we made some research about the validation of the product, and then in the team of Marco, we implemented into the system. So basically, so a few words about the objective and challenges. The idea is to have a long-term preparation. I mean, it's important to have this long-term preparation for extremes if we want to mitigate or adapt the population or the situation to this extreme. And we have also to propose something quite smooth, seamless forecast from the extended long-term seasonal extended forecast to the short-term forecast. So of course we don't provide the same accuracy, but it's important to maintain to have this kind of long extended view and the short-term forecast. That's why it's important to implement, and it has been implemented in one of the service of Copernicus called Emergency Management Service. So the same product has been adapted also for at global scale, and but in the tropical region, it's a specific one for the tropical areas, a bit more accurate because the climatology has been slightly corrected. So what are the challenges? The first one is to define the extreme events. So we have to define a good criteria to have the relatively close occurrence of events forecasted and observed. We have also to define the type of thresholds, if it's an absolute or relative thresholds. And we have also to think about the intensities of the extreme events. So basically for a drought, we have to see if we talk about a certain, just a deficit of rainfall, or if we start speaking about a very extreme and very intense drought or floods. For the assessment of the predictability, so the skill score of the predictability, we have also different type of score and different estimation. The first one is based on the occurrence and spatial distribution. So if we are able to catch the complexity of the distribution of the extreme around the world and in the tropic, in the case of ClimSA, we have also to represent what is the representation of the events in terms of impact, in terms of origin, in terms of processes. This is more for scientific point of view. It's not necessarily important in the operational context. And we have, this is something important also in operational service, for operational services, is all the question related to the uncertainties. So the uncertainties linked to the methodology, the bias we can put in the system, or the uncertainty linked to the lag, the error of the model that usually drift with the lead time. So and the last challenge is the communication. So basically, something quite simple to say is that a forecast is really easy to make. A reliable forecast is quite complex. So we have to communicate an understandable and robust information. Understandable because sometimes, I mean, we know that it's quite complex, for example, to understand an ensemble forecast, a probabilistic forecast of an extreme. It's relatively easy to misunderstood the message we can pass, and robust because it's really important to provide both the forecast but also the skill of your forecast. If you're pretty accurate, or if you know that we have a certain uncertainty related to the information. So this communication is really a big part of this task. So in that presentation, I will go through almost all these points, and I will show you some aspects. So basically, if you are not familiar with ensemble forecast, This is just a small graphic of presenting how it works. Basically, you start with initial conditions. So basically, when you start the forecast here, located here, and what we do is we consider that the observation we have right now are a bit uncertain. We are not 100% sure about the temperature at 3,000 meters of altitude. We are not 100% sure about the wind speed here. We are not 100% of the rainfall in close by. So we have a lot of uncertainties. So what we do is we start with analysis and we perturb the analysis. It's what we call the perturbation of initial conditions. So we start with a certain spread of the ensemble. So basically, we don't simulate one event, but we're gonna make n simulation. N is the number of members of the event. So basically, here it's an example. So you can see that different solution even for the present situation. And with the forecast time, we're going to increase the spread of the ensemble. So basically, each simulation will go to a specific solution. And at the end of your event, we have a probabilistic distribution of the solution. So it's not like the deterministic forecast when we start with one temperature or one precipitation and we go to another one. Here you see that we have this kind of PDF of solution. And this is very well adapted to predict extreme events, and also for as soon as we start looking at more than 2 weeks or 1 week or 2 weeks lead time, because we have too much uncertainty with the deterministic forecast. And in the system, we need both the forecast and what we call hindcast. Hindcast is just forecast, but of the previous events, of past events. And as I mentioned previously, it's easy to make a forecast, but the forecast must be reliable. And to assess this reliability, we need the hindcast, the past forecast with the same system, but in the past, so we can assess the model, and then we can both provide the forecast and the accuracy of your forecast. So Okay, so what are the data we are using to predict, to make this forecast? We are using a forecast system called SIS5, seasonal. It's a seasonal model from ECMWF in Reading. And we have a different, so we have 51 members for the forecast and 15 for the hindcast. And we have a long period of hindcast when we perform the statistic of the accuracy of the model. It's from 81 to 2016. And from 2016 to January 2017, we start operational forecast. So basically, we can provide for you all the forecast, the operational forecast with 51 members since January 2017, with the accuracy based on the period of hindcast. And for the resolution, we use the 0.25 degrees, but has been upgraded to 1 square degree because for 6 months, 3 and 6 months lead time, we don't need high resolution data sets. We have too much uncertainty. We prefer to focus on large scale situations. So it's just 1 square degree. And the observation have been used for validation. It's the GPCP datasets that are used also for another service at the GRC, which is the Global Drought Observatory. So we have all the data from 81-2010 that has been extended up to 2022. So now this is the datasets. So now we're going to talk about the technique to compute our system. So basically, the system is officially it's a FI shift of tail of the SPI. So FI means extreme forecast indexed, based on the SOT on the tail of your distribution of SPI. So I will explain all the steps. So first, you have, for example, for a specific period of time. So for example, you focus on the forecast we are in September for the SPI3, so September, October, November. So the cumulative rainfall from September to November for all the period we have and all the members, this is the values. So the 15 members multiplied by the years of hindcast, and we transform it to, we calculate the PDF. the CDF, the cumulative data, the cumulative distribution function. And based on the CDF, we're gonna fit we're gonna fit a gamma distribution that is indicated here with the line, the gray line. And this gamma distribution is transformed into a normal distribution. That is the transformation. So basically here, we ranked all those values and we performed this, the CDF. The CDF, because it's a bit noisy, because so we fit a gamma distribution to be smoother. And this gamma distribution is transformed into normal distribution. Here, it's the same value, but transformed into normal distribution. You can see the values. So basically, the normal distribution means we have a peak around 0, and we know exactly what is the proportion of your distribution above -1 and plus 1, above 1. And then we can for example, for 1 point, we can see where it is here and is transformed into a value of SPI. This is the value of SPI. And here you see that it's slightly negative, but not, it's in between 0 and -1. And we know that in the normal distribution, between the median at 0 and here -1, we have about, so it's 35% of the distribution that is located here. See, if we are looking at the after -1, it's about 16% of all the cases. It's the sum of all the value here. So basically from -1 to -1.5, we call it moderate dry. It's about 9% of the distribution. From -1.5 to -2, we call severely dry. It's about 4.4%. And lower than -2 is extremely dry. It's exactly the same, but opposite sign for wet conditions. So you see the distribution. So now we transform our cumulative rainfall into SPI. So now how it works. So we have now, that's why we have the extreme forecast index of SPI. So basically here, I give you some example. It's the cumulative distribution function of a normal distribution. So basically you have the median at 0, and you have the distribution I mentioned previously with 16% lower than -1 and 16% above +1. It's a normal situation. But now take a look for 2 examples of forecast for a grid point, which is the blue and the red. The blue represents an extreme case and the red an extreme on the opposite. So how it works, the first result, if we look at the distribution at 0.6, as 60% of the distribution here. If we are above +1, it's the case here, we are above +1, we consider that there is an event ongoing, an event of wet events, because 60% is above 1. It's the way we detect an extreme event. So in that case, we know that we have the high chance of having, for that condition, of having an extreme event. And then we calculate the area here in blue for the intensity. In opposite, if the point at 0.4 is lower than -1, this is the case for the red color, we know that we're in a situation of extremely dry condition. And in that case, we're gonna calculate it, the area in red here. If you look at 0.6 for red, you see that it's close to -1, so it's clearly not a wet case. If you look at 0.4 for the wet case, you see that we are still positive, so we are not, we don't have any warning for the drought condition. So of course it's an extreme, so you can see that the anomaly is everywhere, but sometimes you have an anomaly only in the tail of your distribution, but not everywhere. So we have detected an event, wet or dry, and we have the intensity. But the intensity is almost impossible to understand for a non-specialist, because I will give you that the intensity is 1.5, the intensity is 2.28, you don't know. And also spatially, it can be very different from one region to another. That's why I transform this area into the return period area. So basically, I made the statistics over each grid cell. I make some statistics and I compute the return period. And I put 3 alarms. One alarm is we have a 6-year return period. The alarm number 2, the orange one, is 10 years return period. And alarm 3, which is the red one, it's 20 years return period. So basically, the alarm 3 is almost the maximum you can reach in the. It means that in all the forecasts we have, in the hindcast we have for the from 1981 to 2016, we had almost no cases like that. It's really extreme. So it's extreme, moderate, and low events. And then we're gonna use and we're gonna assess these alarms, and we're gonna see if it's possible, I mean, if we are accurate of predicting wet and dry events with these alarms. So first, if we look at the 3 alarms, so here you have alarm 1, alarm 2, alarm 3. And in red is for the wet dry cases, and for in green it's the wet cases. What I'm comparing is from alarm 1 to alarm 3, so the lowest alarm to the highest alarm. You can see that here the axis is the frequency. So basically it's the frequency of occurrence. So it's a kind of a score. So basically we increase with the alarm, we increase the frequency of the event. So basically more we put a strong alarm, more we have chance of having an event. For alarm 3, for the wet, so the best case, we have more than 60% of chance of having a real case in that event. It's a bit lower for alarm 1. In terms of intensity, of course, you can see for the observed event, you can see that, for example, this is for the wet cases. If we increase the alarm, usually we observe an increase of the event. So we verify that both the frequency and the intensity of the wet and dry cases are stronger when we increase the alarm. So the alarm is both an information about the uncertainty of our forecast and an information about the severity of our forecast. We did some also validation in terms of dichotomous information. Dichotomous means is it true we're gonna have a wet extreme or a dry extreme? So basically, the idea is just to check when I trigger an alarm, 1, 2, or 3, I put 1. When I don't forecast an event, I put 0. The same for the observation. Did I see an extreme? Yes or no? And then we can decompose into this table. When it's yes observed and yes forecast, we call it it. The no, it's the correct negative. And then we have false alarms when we detect, we don't see anything, but we forecasted it. And when we miss an event, that means we didn't forecast an event that occurred. And then we have some score about POD, the false alarm rate, and the equitable treat score, which also the Gilbert skill score, we take into account everything. And about as I mentioned previously, the probability of detection. So basically, the detection, in statistic, we have about 50% of drought, depending the intensity, but in total, we have about 50% of events that have been corrected, forecasted. If it's a stronger event, we have more chance of having it. If it's a mild event, we have a bit less chance. It's about 40%. For the reliability, maybe it's not very important to speak too much on that, but it's just to show if depending the regions, is to see what is the reliability of the model. So we need to be very close to that line. So basically, when we mention a percentage of members associated with an event, we expect having the same chance of observed in the past the event. So we have to be exactly on that gray line. And just what I want to say is that the tropical region is not necessarily better, except for the dry cases. You see that for the dry cases, we have some better prediction, and I will show you in more details the maps. So maybe it's this graphic is much better. By the way, these maps will be shared into the climate station. We don't know exactly how, but I mean, I will find a way to share with you the scores at monthly time scale. So basically here, it's a computation for all the year long of the score. So the greenish, the better. the greener the better. So you can see here, for of course, from SPI 1 to SPI 6, we decrease. It's much more complicated to predict an SPI 6 to a SPI 1. But what is very interesting is to observe that, for example, in over Europe, compared to, in Africa, in most region of Africa, the Southern Africa, the Eastern Africa is much more predictable. Droughts and wet and dry cases are much more predictable than what we can observe in North America, in Europe. And it's mainly because most of the score is driven by what is predictable in the system, and what is the most predictable information is ENSO. So basically, the best example is SPI 6. And if you look at SPI 6, you will see it's exactly the region that are affected by the ENSO, basically the Southern America. You have some part of South and Eastern Africa, and of course, the Southeast Asia. We have also some other indicators like the IOD for the dipole in the Indian Ocean that can drive also some good skill in the ICPAC region. But so it's really remarkable to show that in some region, especially mentioned, so those I mentioned previously, we have a good, because it's comparable to the value we have at SPI 1 in Europe, a good skill score of the drought for SPI 6. So it's a very positive thing, I think, for the project. It's some other impact. I will skip that to go directly to the interpretation and the use of the data. So basically, there's data, as I mentioned previously. These data are available into the climate station. So basically, if you go to the product of the climate station, you will see that there is a folder rainfall forecast. And for the moment, we have one product, which is forecast of wet and dry spells. And if you open it, you see that the project is available from -45 to +45 degrees north. And you have 3 different sub-products from 1 to 6 months. So basically, you have the 3 products available. And then if you select them, you have directly access to the data I presented. So here is 3 examples. I'm very sorry for spread. I didn't include in that. You have just to extend the window and you will get the spread region. That's pity, because with the third La Nina ongoing, we have a very interesting feature of the precipitation in the Pacific Ocean with a strong dipole. But here you see, so it's for September, for SPI 1, SPI 3, SPI 6. And so you have the reddish information that are the 3 alarms related to the dry cases, and the purplish colors are for the wet events with a different return period I mentioned previously. So you can see right now the ongoing forecast. We apply the mask when we have lower, the minimum precipitation is not does not appear. So we should avoid values over the Sahara, for example. And then you have some information, but you have some information about the persisting dry condition or around the Eastern Africa related to La Nina. And you can see also the effect of the increased when you increase the windows of the lead time. So all those data are already available, and you can use it. And I will for sure we will find a way to include also the skill of the models at regional scale for different months, so you will be able to have the forecast and the skill of the forecast together. Okay, so very few conclusion. I'm going very fast on that. We have developed this system. It's already operational now for the SPI, based on the SPI for 1, 3, and 6 months lead time. We have, especially in the tropical region, we have some skill even for 6 months lead time. So it's very interesting for users in those regions. And I didn't present, but we have some sensitivity depending the alarm level or the initial condition. So basically, we have more chance of having a good prediction if we're right now if we observe a dry condition now, we have good chance to predict a dry events in the future, but it's something about the sensitivity. Yeah, so of course we have some limitation, and we're going to try to improve the skill of the forecast. And we have a team, and I'm participating with them on the improvement of the system, and we plan to develop another forecast system based on the multi-model ensemble. So basically, we won't use only CIS5, but we will also use Météo France, METOFIS, DWD, the Canadian one, and the American one. So it's the perspective of this work. Okay, so I'm over now. So I'm open to questions regarding the presentation first, and then we will have this discussion or feedbacks related to what topic you want. So first, if you have any question regarding the product, the use of the product, feel free to intervene. You can write your question in the chat. You can just unmute yourself. Is there any question?
Yes, so I would like to come in.
Yeah, please. Dr. Faka.
Hello, Christ.
Oui.
Yes. Yeah, thank you for the concise presentation. That is really a good improvement, especially on the predictability of the dry condition. At this stage, in terms of the predictor, are you only using the SSTs, or you are combining with any other parameter as a predictor?
But for the moment, we are using the precipitation from the cumulative precipitation. But what we see is that in the region where we have a strong impact of the ENSO, we have an extreme good skill. So of course, we could try to find a way to improve the system by using predictors, atmospheric predictors or oceanic predictors. But the thing is really complicated, because in such case you have to do it for every single region you want to work on. So basically, even at a regional scale, for I don't know, for SADC, for CIMH, they have to make this study for every single sub-region to see what is the best predictor, and what is and it's not guaranteed that the predictor will improve the skill compared to the direct forecast based on the precipitation. So it's a long work. I mean, it's already complicated to do for a specific region. So basically, if I don't know, if Agrimet want to improve the forecast over Niamey, they can make this kind of work of looking at the predictors of precipitation over Niamey, and it's maybe related to African steady waves, cyanide law. It can be related to a different jet or whatever. But these predictors cannot be used in ICPAC, in SADC, because the climatology is different, the system, the weather system are completely different. So you have to apply it in every single region you want to make the forecast. You have to apply a new system, and it's almost impossible to do. So basically, right now, it's clear that for SPI6, the main driver of SPI6 is ENSO. And ENSO, La Niña and El Niño and La Niña are the most skillful variability in the models at such long lead time. So no, I think it's complicated to implement new predictors, and it's clearly ENSO that provide a good prediction in some places. I don't know if there are other questions.
Hi, Christophe.
Yes.
Just a little clarification on what you just finished on. You're saying maybe I might have missed something, but what I heard is when you say SPI6, SPI3, and SPI1, The numbers refer to lead times, right?
Sorry, I didn't get your answer completely. Your question.
Does the number refer to lead time like a season?
Yes. It's 100% forecast. I don't merge forecast and observation. So basically, SPI1, the SPI1 available right now in the system, the last SPI1 in the system is for the prediction of the cumulated rainfall in September. The SPI3 is September, October, November, and SPI6 is up to end of February.
Great. So when you say ENSO or either phase is significant for SPI6, in our region, if we have both IOD and let's say a positive IOD and a positive ENSO, we would find that the Indian Ocean dipole has more influence than the Pacific. So when you say ENSO is more significant at 6, I really don't know if you are considering an isolated case or Indian Ocean should be included in this.
No, sorry, I wasn't clear. In fact, when I was talking about the ENSO, it's in fact in the global map I presented for SPI6, most of the patterns at global scale is explained, the higher scale in most of the region are mainly explained by ENSO. But of course, IOD or the North Atlantic Oscillation has also some skillful, but one of the, I mean, if you look at the impact of IOD worldwide, you don't find the pattern of the skill I got here. It's just, of course, IOD will play a very important role in specific region, and in Eastern Africa, maybe it's, I made a mistake saying that in Eastern Africa, it's because of the ENSO. Of course, it can be also associated with IOD. Sorry for that if I but it's just the global pattern of the SPI6. And if you look at the SPI6, you will find a very high score, skill score in the Southeast Pacific. You will have this very strong score in South America. You will have a lot of impact in Australia. And those regions are highlighted as the region with a strong impact of ENSO. That's why I concluded that. But of course, IOD will have also an impact and is also a bit predictable.
Understood, thanks.
Sunshine, you were, and then Piotr.
Thank you so much, Christoph. Yeah, I wanted to ask, I mean, it's just a follow-up to the current discussion. I wanted to understand if the computation of the SPI is based on what forecasted rainfall amounts in the next coming period, which means it's not necessarily directly derived from the predictor. I wanted to, because I like to assume that this is directly taken from the model output, which has ingested different predictors. So that's where I was now having the sort of like not to follow through in terms of what was currently being discussed in terms of the influence coming from the different drivers and from the different ocean basin and different oscillations. So my question is mainly on which models are you currently using to do the computations? I know there's CMF and whatever, I don't know. How many are you considering to come up with the current analysis that you have? I mean, models that are already in the system. How many are we having? I mean, model inputs that have been considered.
Okay, so first, your first point, as you mentioned, you're right. We are using CIS5 cumulated precipitation, and we compute the SPI based on the cumulated precipitation, forecasted precipitation. So it's the product is 100% linked with the forecast precipitation. Okay, this is the first point. Then when I mentioned ENSO several times, it's just that when I look at the skill of my forecast, I have a better skill in a region that are affected by ENSO, and I explain this variability of skill because of the ENSO impact, and you have also IOD impact. So, but I didn't use predictor for the forecast. It's on 100% based on the precipitation forecasted. For the system I'm using right now, as I mentioned, it's CIS5, so it's a seasonal forecast version 5 from ECMWF. We have in Copernicus access to other models. I mentioned also Meteo France, MetOffice, UK MetOffice. We have access to DWD. We have access to NOAA also as well. We have access to the Chinese, the Canadian, etc. The ongoing work on multimodal approach, with the multimodal approach we're gonna do, the idea is to compare the added value of using a multimodal approach compared to my system, which is a bit which use only one system, but it's much complicated because we have different steps. We correct the data, we transfer into return period, we adapt the threshold, we compute the return period, and so on. So for the moment, there is no for the moment, we don't think about adding more model with this methodology. But if we realize that we improve a lot the forecast based on the multimodal approach, but the multimodal approach with a more common use of the multimodal approach. So basically, it's just a percentage of model associated with an extreme. If there is a very added value compared to to the forecast I presented today, the idea is to maybe shift to the multimodal approach and the normal system, and maybe that system I presented to you today, but for 3-4 models. So, okay. But for the moment, it's only based on CIS5. There are ongoing work with 6 other models. So but I will keep you informed.
Thank you so much. Thank you so much. Yeah, it would be good to see how the other models perform.
Yeah, yes, we are very interested as well. Okay. Thank you. Piotr, if you.
Thank you very much. I actually wanted to add something that Sunshine already added, that, that's the whole discussion about sources of predictability and relationship between whatever is there emerges from your system and ENSO IOD. It's sort of irrelevant because it's all filtered through the model. So if your CIS model is sensitive to sort of shows sensitivity to a particular mode of ENSO or IOD or combination of those, then it will all emerge there. But you're not taking this into account explicitly. But my question is about something else. So I understand you're calculating those SPIs 1, 6, and what was the other? What was the last one?
136.
136. So this is like in classical SPI sense. So this is like a one, with a base time of 1 month, 3 months, and 6 months. Is it?
Yeah.
Okay. So now you are calculating it ahead of the forecast month.
I didn't get it.
So your SPI 6, like if you do a forecast in August, your SPI 6 will be for the period between August and 6 months ahead, which will be with April next year. Is
okay.
Sorry, the February next year.
February, yeah.
Yeah. So that's sort of a rolling.
Yeah, it's just I just increased the initial time for the 3 SPI is the same. So basically, for September, so for the ongoing forecast for September, SPI 1 is September, SPI 3 is September, October, November, and SPI 6 is from September to February.
Yeah. Okay. No, I was wondering. Okay, so with this thing 136, it sort of makes sense, but because quite often you have this sort of a hard cutoff of your SPI at the end of the period rather than in the beginning. So what is important, for example, it might be a 3 months SPI that is that ends in January.
So shifted by 1 month, you mean?
Yeah, no, I mean not necessarily, but you see, because or DJF, your classical center of the season, DJF. You see, and in this system, what you can do either 6 months to DJF, or you can do sort of 3 months to, unless you are already in DJF, so you only calculate that. So perhaps it would be worthwhile looking at defining not just the time base of your SPI, but also the period of the SPI.
So, but if I understand well,
what I'm saying. So
It's 3 months, but for different period. So basically, in September you have September, October, November, but also October, November, December.
Yes.
And yeah,
something like this. Or okay. So I think it would be like this. That, for example, 3 months SPI ending in January or in February. You see, and then you can forecast it approaching closer and closer, but that period stays, the target period stays the same, and the target SPI stays the same.
Yeah, it's
because then you are looking at say a center of the rainy season or the onset of the rainy season, and you see as your forecasts approach that you keep on forecasting the same thing better and better.
Yeah, it could be implemented. I'm a bit afraid about, for example, if we look at SPI 3, but for 3, I mean, from now, if I'm looking at December, January, February, I would be a bit afraid about the skill of the.
No, I know, but it's
because it's so you start your forecast, your cumulative rainfall at more than 2 months after the initial time of your model.
I know.
That's.
But you see, why I'm saying this is because you see, for example, you have I mean, in the onset of rains, it would be, I think, critical that you want to know what's the sort of drought conditions, what's your forecast for drought conditions at the onset.
Yeah.
You see, and that onset is it's fixed in time. So that's what you want to sort of forecast and get better and better, warn about, not necessarily this sort of 6 month rolling 6 months that are all right. Thank you.
Yeah,
just
but
my thoughts.
I have to see what we can do. That could be also a way to improve the system. Yeah. Thank you, Piotr, for your comment. So I noted this. Okay, thank you. I think time's flying. If we can shift to the next part of the discussion, that normally should be the biggest, but unfortunately it's already late. But we are completely open if you have any feedbacks, and we are very interested if so. Basically, we received the first feedback from Agrimet saying that for the moment there is no use of the climate station. I don't know if other RCC can maybe just give us an update about how you use it, if you use it, and how you use it, which variable. Do you want to mention something from, I don't know, I see a lot of people from ACMAT, for example. So I don't know, ACMAT, you can start if you can give us some feedbacks about the use of the climate station. Is there somebody from ACMAT that want to intervene?
Hello, this is Pierre from ACMAT.
Pierre, yes.
Yeah. What I would say that even us here in ACMAT we are not yet start the usage of the climate station. I mean, today maybe for me, it's my first time to attend this demonstration, and we have not yet started to use the climate station.
Okay, and is there any reason or any specific problem to? Maybe it can be related to different things. Is there any difficulties for technical difficulties or scientific problems because missing data or something like that?
No, and now maybe what I would say is just that maybe we're too busy to really use that. For now, we're just using our own system that we have in place to generate things, and that from now we are going to add this, go there and see what we have, what we can shop from there. Sunshine have a question. Sunshine can also say something about it.
Yeah, Sunshine, please.
Thanks, Pierre, and thanks, Christophe. I think for us, it's not really that I remember the last session we had, if I remember very well, it was more on discussing the type of data sets that should be ingested into the system. So the next session that we were anticipating to have was a session where now we can go through the system in terms of introduction as users of the system, because the work that has been going on all along has been more like configuration and setting up the system. So I only got to hear recently the system is live and we can use it. So I was expecting that probably we'll have a session. So I was thinking that today probably is one of those sessions where now we can have work directly with GRC for us who want to manipulate what is inside. I've used the system myself. I've gone inside the system. Yes, I've accessed certain things, but I was working in the dark. So it would be good to have somebody probably to have a run through, as Pierre was saying, have a run through for the climate experts. Because I think the work that has been done so far has been with the IT experts within ACMAT. So I think if we can have one session, it will help us now to start utilizing the system efficiently. Thank you.
Okay, thank you. Marco, you want to?
Yeah, I think it's a very good remark. So we organized our sessions in order to have installation first, then the configuration, and also we presented how to operate on at least some components like the acquisition, but maybe that was still involving the IT experts that were the actors of the installation. So maybe on our side, we should consider probably having in the next regular meetings like today, a training or at least a workshop, something, say, working together on the operations of the system and paying attention in inviting the climate experts. So not really the one that are in charge of the installation, that they did their part and are going to be involved for other parts like the upgrades or if there is any technical difficulty. But now I think we are ready to address the users of the system. So to organize a number of sessions where we present the different components to the users, so the climate experts. So it was it's just a bit an elaboration of intervention of Sunshine. I don't know on because I see that now we have a lot of RCCs participating. So I don't know ICPAC, what's the status there, if somehow is along the same lines or is some or is slightly different.
For ICPAC, you mean?
Yeah.
Yeah, ICPAC, we can Eunice or Romeo, I don't know. No, Romeo is ACMAT, pardon, sorry. It's Eunice.
Yeah, from our side, we of course did a little bit of analysis a few months ago with the tool and were able to add the hindcast data, but at some point, I was not able to extend the hindcast period. It could not ingest. And I was discussing with my colleague Anthony, and we thought maybe you are working on the system and you had frozen it. We are sorry we didn't get back to you to see what the problem was. And we've not been able to do much from then. And I don't know if I lost something because I just logged in and I can only access the dashboard. I don't know how far my other colleagues have gone, but they are now they're attending the UMETSAT workshop in Tanzania and they are not able to join. I don't know if others have been able to work independently, but that's from my side.
Okay. CIMH?
Sorry?
We're asking to every RCCs if they are using the operationally now the climate service or climate station or not yet, or if they have technical issues or some feedbacks.
So we only a couple of days ago we actually got to load everything again, most recent version of the climate software. So hopefully by next week we should have an update. Okay. And the regions were recently applied, or the domains were recently applied for our section.
Okay. And I think I asked to agreement SADC. So Piotr, or I don't know if there are.
Tiro, do you have any update?
Do you have any update?
No,
Tiro.
I think the system was just upgraded last week, and we haven't had time to start using it. Yeah.
Okay. Thank you. Okay. Is there Abani? Ali, I see your Ali.
Thank you, Christophe. I will to add within this request the demonstration to import external data to the station and process them. Here internally, users has been asking us if it is possible to bring external data to and then get your map and this thing. So within the demonstration, if we can have that one, that would be great. I have also noticed that the system has little behavior, very sensitive to availability of bandwidth and the zoom in, zoom out. There are some important buttons for validation that are hidden on my screen when I'm using. So sometimes I need to zoom out and get the full shape. And also if the internet is not a good one. I don't have the normal reaction of the system. It came very late. So some may think that the system is not working, but it's working perfectly. So my first comment is exactly what Mr. Mulai Umaru from Agreement said. The system is perfectly working, and we just need the internally thematic users to be using it so that we give you full feedback. Thank you.
Thank you. Okay, thank you very much. I think we asked to everyone. I don't know if there are other comments related to the, so we
yes.
Dr. Faka, yes.
Yes. My understanding for today's mean like the thematic expert, the climate expert have not yet received training on the operational use of the tool. If I consider comment from Ahmad that up to now it was most on the IT side for the installation configuration, and they would like to have a specific training on how to use the tool. Is it correct, my understanding?
The thing is that there is maybe a communication issue, but we started this regular meeting is mostly for users. Of course, the installation it's mostly focused it's for the ITs. The regular meeting is for the use and the feedbacks. Of course, IT can join the session if there are especially technical issues, because it's also a way to communicate with us, even if they can send a message, direct message to us. But those regular meetings are mostly for everyone, and mostly also for the users. And the first meeting we did in August was the functionalities and tools included into the climate station. This session has been recorded on Microsoft Teams, and it's typically it's explained the use of the climate station. So we can propose, I take notes of the recommendation. So basically, it's clear that we need one specific on the data sets. And what we can do is when I will finish and I will update this meeting into the Microsoft Teams, I will send the link for this video, for today's video, and I'll resend the link for the basic usage of the climate station with the different functionalities, or to plot a map, or to use the data set, etc. If the users they still have they need update or better information or whatever, what we can propose also is to make a new meeting, regular meeting, on dedicated on that. It's clear that we have to improve the communication to really say that these meetings are mostly for thematic experts. It's for users, thematic expert, climatologists, and so on. So the idea of this meeting for the 2 days meeting was exactly the same. So we made one. Maybe we didn't communicate enough, or some specialist thematic expert won't be able to join. But that's why I will put again the link of the video of the previous regular meeting, so they will be able to see the video. And if needed, there is no problem. We can remake this kind of meeting more specifically for specific tools or specific application or whatever. So this is the situation.
Yeah, that question I was asking just to prepare ourselves for the coming forum, where we like really to have experience, and the climate station is one of the tools we are going to present to the public, and we like really to have a feedback from you RCCs in terms of the practicability, the user-friendly, and the output, how useful are the output, because that is really one of the ClimSA flag. So we need really people to master it and also to give a feedback for any other improvement, as Christophe really committed himself to improve the system. So we are advising really the RCC to give us the feedback. You recall that even during the steering committee, the UaF-CS General Secretary also pointed out that we need people to give us the feedback for those who are using under the pilot phase, so that when you will become widely distributed to all the member states, things could be more better version than this current version, where we're expecting to get your input for the first use, so that wide use could be in the advanced version. So I'm really begging our RCC people to make effort. For the GRC, maybe I would like also to propose to have the user manual, so that video and the user manual, both of them, anyone can go through and also follow up and to train the self-training himself. Thank you.
Yeah, Marco, you want to?
Just thanks for very much. I share your idea. Fakar, we decided to anticipate the deployment of RCCs, really to also have their feedback. So this idea to build on the feedbacks from the regional institution in order to improve the product, the platform for the national level, I fully share as an idea. The user manual is there. We are going now to very soon to, now that we deployed 1.1.1, which was my priority for us during summer. We're going to start creating these short movies, short video tutorials that complement somehow the user manual when it comes to very specific operations on the system. So user manual explain the components of the system, the user interface, doesn't enter the detail of some specific operation which is going to be done through this video. So this is something we are now start working on. Yeah, back to you.
Okay, thank you. If there are other questions, remarks? Okay. If no, in any case, you can send us a message if you have a comment or something related to the use of the climate station. Of course, we're you feel free to send us a message, I mean, an email or about the following meetings. So we took note about the needs of presenting the data sets and maybe another overview of the usage of the climate station. That could be an idea for the next one. As mentioned by Dr. Fakan, so basically the idea is to make one, I mean, every 2 weeks. In 2 weeks, it's exactly in the forum, so I think we won't be able to do it. So what I can propose is to do the next one the week after the forum. So it's basically the first week of October on Thursday, 3 p.m. and we will communicate with you, of course, the link and the topic of this meeting. Again, it could be related to the data sets included into the climate station and basic functionalities. Okay, thank you. I think if there is no other comment, we can stop now this meeting. Thank you again for joining us. Yes.
Yes, thank you, Chris. Sorry, let me make this comment also as a closing remark that our RCC, this is a good opportunity for us to improve our climate services tool box we are having. You are having already your own tool. We as a ClimSA, we are bringing you a new tool. So it is depending to you to tell us which kind of challenge you used to face with your own tool, which we can really address in the climate station. So the more improvement will come from your side, RCC, by presenting your requirement, your challenges, so that climate station, ClimSA climate station can take it on board. Thank you.
Yes, thank you very much for this last comment. Okay, thank you very much. I will stop